So now let us do a last minute revision on the subject of physics for class 12 cbse. So we'll take up the chapter number 7, so that is alternating current. So here you can see in this particular slide a table consisting of some important formulas at a glance. So we have the physical quantities, their formula and their units, and also the dimensions given in this table. So we can make a note of the first physical quantity, so that is alternating current and voltage. So given by the formula E equal to E naught into sine of omega t plus phi, or E equal to E naught into cos omega t plus phi, and current I is given by I naught into sine omega t plus phi, or I equal to I naught into cos omega t plus phi. I RMS is given by root mean square equal to I naught divided by root 2, and the value of root 2 equal to 0.707. So therefore we can write this as 0.707 I naught, and also E RMS equal to E naught divided by root 2. Since the value of root 2 is 0.707, we can write this as 0.707 E naught. And the phase relationship for R is equal to no phase difference between the voltage and current. And for L, we have the voltage leads the current by a phase difference of pi by 2, and for C, the current leads the voltage by a phase difference of pi by 2. So therefore for LCR circuit, if F is greater than Fr, so then we can write phi equal to tan inverse of XL minus XC divided by R, or we can write this as phi equal to tan inverse of VL minus VC divided by R. And further, if F is less than Fr, so then we can write tan inverse of XC minus XL divided by R, or this can be written as phi equal to tan inverse of VC minus VL divided by R, and these are unitless. So next, for the physical quantity of reactance and impedance, so we have the inductive reactance given by XL equal to omega L, and the capacitive reactance is given by 1 into omega into C, and the impedance of a LR circuit Z is given by square root of XL square plus R square, and the impedance of a RC circuit is given by Z equal to square root of XC square plus R square, and the impedance of an LCR circuit is given by square root of XL minus XC whole square plus R square, and the unit is in ohms. The resonance frequency is given by Fr equal to 1 divided by 2 pi square root of LC, and the angular frequency omega R is given by 1 divided by square root of LC, and its units are hertz or radian per second. And for the physical quantity of quality factor, given by Q equal to 1 by R square root of L divided by C, also equal to omega R divided by 2 into delta omega, and it is further equal to omega R into L divided by R, and that can be again equal to 1 divided by omega R into CR. And further, for the physical quantity of power dissipated in an AC circuit, in a pure inductor and capacitor it is equal to 0, and in a pure resistive circuit is given by I square R divided by 2, and in a combination of L, C and R circuit we have VRMS into IRMS into cos phi, and this unit is given in watts. And for the power factor, cos phi is given by R divided by Z, and for Watt's current we have IRMS into cos phi, and its ampere is the unit. For frequency of LC oscillations we have Fr is given by 1 divided by 2 pi into square root of LC, and its unit is in hertz. The energy of an ideal LC oscillator is given by half Q square divided by C plus half into Li square, and that is also equal to half into Q naught squared divided by C. Its unit is in joule. The transformation ratio and the efficiency of a transformer is given by, so here the transformation ratio is given by, so Vs divided by Vp, and that is equal to Ns divided by Np, and the efficiency eta is given by, so Vs into Is divided by Vp into Ip, and that's also equal to P naught divided by Pi and it's unitless. And here you can see the graph of the variation of resistance versus the frequency, so which is parallel to the x-axis. And further you can see the graph of the inductive reactance versus frequency, so varies proportionally with respect to inductance and frequency. And the capacitive reactance versus frequency graph, so is as shown here in this particular graph, and it's not a linear variation graph. And for a purely inductive circuit, the voltage leads by 90 degrees, and for a purely capacitive circuit, the voltage lags by 90 degree, and for a purely resistive circuit, the voltage and current are in the same phase. And in an RL circuit, the voltage leads by some angle equal to phi, and in a purely capacitive resistance circuit, the voltage lags by a current, so of equal to some angle phi. And in an LCR circuit, the voltage and current variation is as shown in this particular graph. And the bandwidth of a series resonance circuit, where we have the lower side band represented by omega 1 and omega 2 represents the upper side band, and the difference of these two is nothing but the bandwidth at two intervals given by I equal to E naught divided by R into root 2, and also I naught equal to E naught by R. So thus we have made a last minute revision on some important topics and graphs, and also certain formulas at a glance, and understood about the chapter number 7. Okay, thank you.